All right, we're going to start on 8.4 today, and that'll be almost halfway through the Unit 1. I'd like to make an announcement because I know some of y'all are starting to have cardio infarctions. Because you think you're supposed to have a test now and all this, and the homework's going to end, and the walls are going to come down. You need to worry about two things. You need to worry about where we are on the outline and where I am in class. That's the only thing you need to worry about. Because when we get to the end of the outline, if you'll look in your outline, everybody should have them because that's the most important page in the handouts. It says that we're going to 8.5. Okay, I'm covering 8.4 today. All right, so we're probably talking about a test maybe by the end of next week. All right, but you don't need to worry about that because I pull the test up in class, and then after I pull the test up, I do what? I assign the dates. When I assign the dates on the test in front of y'all, in front of everybody, when I assign the dates on the test, I then assign the dates on the what? On the homework. So nobody should be worried about any dates. The only people that I find that worry about dates in my class are the people that what? And what? That's the ones that worry about the test. I meant worry about the dates. So if you're doing what you're supposed to, and you're up to 8.3 homework, and you're sending questions on 8.2 and 8.3 or whatever, then you're doing what you're supposed to. If you haven't hit a lick at the homework at all, then don't be mad when I assign the dates and you got to work all night to do it. My job is not to supply you with a date to procrastinate. So you just take what you want to and read the outline and follow me in class. So that takes care of that question. Well, Hubert, the date, don't worry about what my lab's plus. You need to worry about what I'm doing in class. I get so many people, and it's not your fault. Y'all are conditioned. Y'all are conditioned for the professor that says we're going to have a test Tuesday, and everybody be here Tuesday because we're going to have a test Tuesday. And everybody needs to be there Tuesday. That's not the way I do things. I do things when the class tells me to do it within a reasonable amount of time. If the class tells me that they don't know this material, then I'm going to stay on the material for a reasonable amount of time until the class gets the material. And when I stop getting questions, that means the class what? The class understands the material.
Or they're just really lazy.
Okay, so I'm not a conditioned professor that says, okay, we got to get to finish with chapter 8 by 9:13. Okay, 9:13's here. Whether you know it or not, we're going to have a test. That's not the way I teach. So let's get on with the class today, and hopefully y'all procrastinators won't worry about it anymore. So, chapter 8, trigonometric functions and applications. This section is where you're going to have most of your test questions come from. Okay? I'm not worried about digits. All right, here's the first question. This is when you take everything that you know about right angle trig and you use it. So, solve a right angle ABC with A being 34 degrees, 30 minutes, and C being 12.7 inches. I want you to draw a picture because that's what most of this section is drawing a picture. And again, this is probably going to be anywhere from 70 to 80% of your Unit 1 test. These questions that are in this section. Because out of all the sections that we cover in this unit, 8.4 is the most practical application in different areas. So we're going to draw a picture. Of course, it's going to be a right triangle because we haven't talked about law of sines and cosines yet. So it's going to be a right triangle. And we know that angle A is 34 and we know this is angle A. Well, if this is angle A, then this side over here is what? Side A. Now, some of you may not remember this, but in geometry, you were told that corresponding sides, alternate or opposite side is to the angle or whatever. I'm not going to get into that. But you were taught this in geometry, and then if you had some pre-cal, you were taught it in pre-cal. So that's angle A. It says C is 12.7 inches. What has C always been in trig for you?
Hypotenuse.
The hypotenuse. Okay? So C is 12.7. And that leaves B. Well, this is 90 degrees. So that means this is angle what?
B.
Therefore, this is
Side B.
Now, fill in all the blanks. Oh, blowing up. Oh no, Miss Crittenton is trying to get in. Bless her heart. We just forgot about her. I don't know why Oconee cuts it off every time. I'm gonna have to tell them not to do that next time. Y'all remind me to tell them not to cut off the TV. Or not even Skype. Bless her heart.
She's Wi-Fi schooling.
We don't like you, Miss Crittenton. We don't want you to be in here.
Well, I'll leave.
No, look, there's a student in the previous class, and he cuts the Skype system off for some reason. I'm gonna tell him next time not to cut it off.
Yeah, that would be helpful.
Or if you see him, he's in there. He's usually the last one in there. Just tell him not to cut it off. If I don't tell him, because I told everybody to remind me to tell him not to. But anyway, I went over an announcement about the dates today. Don't worry about dates in My Labs Plus. Okay? Don't worry about that. Because I'm going to go in. If I haven't done it, has anybody looked at the homework? Have I changed it yet?
No.
Okay, it's still due when?
Thursday.
Okay, y'all be all right. I'll change it when I get some time. I'll change it. I'll probably leave it open. Okay? I'll leave it open. That way the procrastinators can just go freaking crazy.
Is it 8.1 through 8.3 that's due?
No, it's whatever's on the outline for Unit 1.
Oh, okay.
8.1 through 8.6 or 8.5 or 5.5. I could include, I think I might include 8.6 and 8.7 because that's just calculator drills. So I might include 8.6 and 8.7, and I might go ahead and I'm going to take some of the homework questions off because I just want you to be able to use the calculator. All right? So that'll be some easy questions for you on the Unit 1 test. So let's go ahead and do that. Everybody look at your outline and put 8.6 and 8.7 in Unit 1. We're not going to cover it very much in class. It's just I'm going to pick some questions. Don't start on it yet. Don't start on the homework yet, okay? I haven't even assigned it yet, I don't think. But I'm going to go in and modify it. It's just going to be 3 or 4 questions in each one. You're just going to, because is anybody going to be asked to draw the sine curve? No. You're always going to be graphing it. So whether you're in the Excel spreadsheet or whether you're in the graphing calculator. The days of you saying, oh, well, that's pi over 2, that's no more. So I'm just going to do some calculator drills for 8.6 and 8.7. You're probably talking about 10% of your test. Out of 8.6 and 8.7, 10%. I'll figure that up later, but you're only talking about 1 or 2 questions out of 20 for that 8.6 and 8.7. But go ahead and move it. Put in your notes, 8.6 and 8.7 will be on Unit 1 test. But do not do any of the homework yet. I'll address that when we get there. Okay? All right. What happened?
You moved the page.
Okay.
8.6, 8.7. You'll address it. Start.
There we go.
How you find the lines?
I'm changing this to black. All right, so my little man
I remember how to do
is
this.
standing right there. So his foot is on the adjacent and the what? Hypotenuse. Now, this is where you have to, the little man tells you what to use. Okay, so I'm going to go over here and I'm going to say sine, cosine, tangent, Oscar, add, A, up, out. Now just put that over to the side because I've got the angle of A. So I've got to figure out which trigonometric function because I've only got one what? I've only got one measurement, and that is the what? The hypotenuse. So I can use either the sine or the cosine. Okay? And it doesn't matter which one you use because you're going to get, the opposite you're going to use. So I'm going to use the sine. Okay? So I'm going to go sine of 34 degrees, 30 seconds, or 30 minutes, is equal to Oscar had. Well, which one do I have? I have the half. So 7 on the bottom. And that leaves me with opposite, which is going to be what? Little a. And now you just multiply both sides by 12.7. And somebody crank that out for me. And please, I need 2 people to verify it before I write down the answer. Because some of y'all I don't trust. What'd you say? I got a 7.2. So I have another 7.2. Well, Pendleton's not going to say anything, so it's either up to Easley or Oconee. 7.2, going once, going twice.
That's up.
Do we have a 7.2 confirmed?
Yeah, I know what
Yes.
the slides are, but
Okay, thank you.
don't have it.
7.2.
You could start with sine or cosine. Doesn't matter.
Now, what if I wanted to use the cosine?
You have to find.
Then I would do cosine of 34, 30 is equal to and adjacent, which is going to be side B over what?
12.7.
12.7. Now what? Multiply both sides by 12.7. Somebody do that for me.
I got 10.4.
I got 110.4. That means I'm waiting on somebody to confirm it.
10.4.
Thank you.
That's right.
10.4. So now I have my sides. Now I got to find angle B. I can put my little man up there. I could do that.
Can you show us how to do this in the calculator? Because I'm not getting it right.
I'm sorry, what?
Can you show us how to type 12.7 and sine 34 degrees 30 feet in the calculator?
Yeah, sure.
Yeah, really 0.7.
Because I'm not.
Make
getting-
sure it's in degree mode.
Oh,
Oh, it's got to be in degree.
Yep, because we're dealing with.
Yep, we're dealing with degrees. Yep.
Oh, okay.
know that 30 minutes is
About that.
1/2 of a degree.
Oh yeah. Yeah, that's even better.
You could just
That would even work even better. Yeah. That would be more confusing.
Easy.
Let me get out of this.
Okay, yeah, I got it.
You got it?
Yeah, I
So
got
it
it
was,
now.
okay, so it was degree function?
Yeah.
It's a degree function, yeah.
Okay. All right, be glad to, I'm glad you spoke up. Squeaky door gets what? Grease. I don't say OIL. Okay, so I want to keep my, oh well. Now, let me ask you a question. Is that the only way that you can do this? No. Oh, we got to find angle B. Okay? There's 2 ways to find angle B. Now I'm going to go over another method here in just a minute. I'm doing different methods because I want you to understand. I want you to understand that if you put your man at a certain angle, what you can get from it. See, you know, I got several degrees. I know that there's other ways to do this, okay? I could have done the 7.2 and done Pythagorean theorem, 12.7 squared minus 7.2 squared, and got B. I could have done the 10.4 first and done 10.4 squared minus 12.7 squared, square root, and that would give me A. Okay, I could have done that. Now I could either do, the trigonometric functions, or I could say 90 plus 34 is 124.30, and then that would give me
56.
56.30 or 55.30, something like that. Say I could do that. So there's several different ways. So I don't want you to say, well, you have to do it a certain way. You don't. There's probably 5 or 6 different ways. So here I'm just going to do a little man. Hold on a second. Oh, well, I just totally screwed that up. There. Okay. I'm going to put my little man right here now, and I'm going to do it in blue. Because I'm changing it to a different color. That means I'm moving my little man right here.
Oh, you got a line.
I did get a line finally. There we go. All right, now I'm putting my little man right there, and his foot is on the hypotenuse and the what? Adjacent. So that means that this side is the opposite. Now, I don't have the angle, so I'm just going to say, let's see, I have B. I don't know what's going on with this board. All right, but B is 10.4.
That's really weird.
I don't know what's going on with it. Equals. It's just having connection.
That one did.
I don't know if y'all can see this, other campuses, but it's blinking off and on, and I don't know what's going on. 10.4, and over here A is 7.2. So pick one. You want the tangent? Opposite over the adjacent? We'll do the tangent. Tangent of theta is equal to opposite, which is 10.4 over 7.2. And theta is equal to the inverse tangent of 10.4 over 7.2. So take your calculators. Now we said that this angle is already what? 54, 30? 55, 30 or 54? Which one was it?
55. It was 55:30.
55:30? Yeah, 55:30. We already said that by the Pythagorean or by the 180 degrees. So somebody take 10.4, divide it by 7.2, and take the inverse tangent of it for me.
55.3.
I'm sorry, what?
55.30.
There you go. And that's your answer. So could I have done the sine? The sine, opposite over hypotenuse. Opposite would be 10.4 over 12.7. Take the inverse sine. That's why these things are so, these questions right here are so applicable on a test, is because if you can do these problems, then you've taken basically the first 2 sections of this trig and you've got it. Okay? That's what this section, that's why this section is so important. So if you can do 8.4, then you're good to go as far as the test goes. So let's see what they did. Let me erase and see what they did, and y'all hopefully check to see if we got the answers right. I don't know. I think this computer is fixing to blow up.
The Russians must.
It's not letting me. It's not letting me do anything. So
Whoever knows too much about the Russians.
yeah, that's it. I know too much about the Russians.
Man.
I got asked this morning what do I think about feminists. feminism, because somebody's teacher's trying to tell them that they should think this way and think this way. Ain't got no use in that. Anyway, I'm trying to get this thing to work. Y'all just bear with me. I'd like to hit this. It's just doing something crazy. I'm just going to hit enter and y'all just look. I can't. 5530, we got that. I can't see any of that.
What?
7.19, we got 7.2. So you see, they started with finding angle B, and you could have done it that way. So do you get the same answers no matter what you do? Yes. All right, try this one.
Well, as long as you do it right.
Well, that's assuming that you have an inkling that you know what you're doing. Yeah. All right, so try this one. Solve the right triangle ABC if side A is 29 and side C is 53. Of course, if you're given two sides, you're going to know right off what to do first. If you're given two sides, the first thing you're going to do is Pythagorean theorem. Speaking of which, I want to ask y'all a question. Have you had any teachers trying to indoctrinate you?
How do you mean? Useful.
When you're a teacher, you're supposed to explain stuff and let the students decide, versus telling you how to think.
I'm using Pythagorean theorem to find missing side.
Nobody's saying
Not really. I'm
you will.
mostly self-taught.
You will. Because they're out there. I make fun of stuff and I talk about stuff, that I think is ridiculous. But I don't tell people how to vote and I don't tell people how to think. Two things I don't believe in at all. And I don't beat people over the head with a bat if they don't believe the same thing I believe. Which, for some reason, we have a lot of people these days that if you don't agree with them, you're either crazy, racist, or you get beat up for it.
Age,
All right. First of all, what is the right angle? What is that always going to be? Angle what?
90.
It's going to be angle C because across from angle C is what? Side C. So this is always going to be angle C. And across from angle C is side C. Now, does it matter which one is A or B? Not really. Okay. Now, they give you enough information. You know that side C is always going to be the longest side. But they don't really tell you 53, 58. They say side A is 29. I'm just going to take a stab at it and say A is right here. I'm going to say A is right here. Now, I will tell you that most of the time, angle A is going to be down here. Now, I don't know why, but they just do it that way sometimes. I have no idea. Now, of course, now that I said that, when I bring up the picture, it's going to be totally past backwards. But anyway, it doesn't matter because you're going to use the same numbers. So, this would be angle B. So, this is side B. So, I want to find side B, and B is equal to the square root of 53.58 squared minus 29.43 squared. Now, I'm assuming that mostly everybody in here has seen or heard of or used the Pythagorean theorem.
Yep.
Because I'll be honest with you, if you haven't had pre-calculus or something to that effect, you really shouldn't be intrigued. But anyway, if you need it, it's right here. C squared is equal to A squared plus B squared. And you can derive any one of the sides by taking the square root of the inverse of the other. So if I wanted A, then C squared minus B squared, square root. If I wanted B, then that'd be C squared minus A squared, square root. So you can derive anything you want to off the Pythagorean theorem. All right. So somebody give me the final answer and give me 2 digits, please.
Got 44.77.
Got 44.77. Anybody got a?
That's right.
I got it.
All right.
Hold on a second. I'm trying to get rid of this. Okay, 44 point what?
77.
77.
So that's this angle right here. I mean, that's this side right here. 44.77. And now you can find anything you want to. Since I have my hypotenuse and I have my opposite, I'm going to do the sine. Sine of A is equal to the opposite, 29.43, divided by 53.58. And A is equal to the inverse sine of whatever that is, 29.43. I'm getting irritated very much. 53.58. And somebody give me that angle, please.
33 degrees, 19 minutes.
33.19. Now, you use a trigonometric function. I know you can use subtraction. I don't want you to use subtraction. I want you to use another trigonometric function to find angle B. Because I think everybody in here can subtract. I'm not going to test you on that. I need to know if you know the trigonometric functions. So I want you to use a trigonometric function, I don't care which one you use, to find angle B.
Yeah, 33.31.
So I'm going to go over here and I'm going to erase this. And this thing will work. Hey. We're going to cut class short today. Because I'm not putting up with this. This is aggravating. Y'all can't see this, but every other second this screen goes bonkers and it won't work. I'm having all kind of issues over here.
Can you tell me how you got 19 minutes?
I was told 19 minutes.
I got the 33.
Whenever you do the
What?
Whenever you do the calculation, it should give you 33.32, and you multiply the 0.32 by 60.
Yeah, the conversion of minutes to decimal to degrees, you multiply by 60.
Oh, I got it. I forgot about that.
Yeah, that's not a big deal, okay? That's not a big deal. If you I'm going to be very lenient with that, especially when it's in decimals, because you never use decimals. But don't get me started on that. So I'll just go ahead. I'll be very lenient about that.
Okay.
I'm going to put my little man right here. And I'm going to just pick one. Cosine. Cosine is equal to what? Cosine of B. Oscar had A hump. So my A is what? My A is 29.43 divided by 53 58. So B is equal to the inverse cosine of 2943 over 53.58. And somebody crank that out. And there is a conversion on your TI. You can actually go in and change it. Okay? Now I'm not going to, you have to go to math. I think it's called decimal degrees. You have to change it. You can actually do that. It'll change it. But you have to read up on your TI to do that. Somebody tell me what you come out with. We know it's going to be what? Let's see, that one's, what was 33? 33 and 90 is 123. Dang old 57 something, 56 something. What is it?
56 degrees, 41 minutes.
56 degrees, 41 minutes. What's the decimal?
56.68.
Does that help you out, bud? I'm interested in you getting the answer, okay? I'm not interested whether you, I mean, it's going to be a test question, yes, can you convert? But I'm going to be honest with you. If I'm grading your paper, or if you come to me and say, look, I did the math right, I just didn't convert it, then I would give you at least 3/4 credit on the test. You see what I'm saying? Because you did the work. This blinking and flashing is getting on my nerves, giving me a headache. Can y'all see what's going on over here? Pendleton?
Yeah.
Do y'all see it flashing?
No, it's that hurricane.
Yeah.
That drives me crazy. That means it's here.
No, that'd be crazy if it hit here.
Yeah.
So now, regardless.
29.43. Did we get that? Yep.
Friday,
56.68. See, they're putting it in decimals.
I like decimals.
Yeah. But remember, that's not what the real world uses. Okay, let's talk about these two guys. Well, let's talk about a horizontal angle, another application in the real world. A horizontal angle versus a vertical angle. Now, if I was to ask you what a horizontal angle is, give me an example of a horizontal angle and give me an example of a vertical angle, could you do that? A horizontal angle would be like the curve of a highway. That's a horizontal angle. A vertical angle would be the highway going up a mountain. That's a vertical angle. Now, you need to know the difference between the two, because if you're going into calculus or you're going into engineering, you're going to have to take some kind of class, whether it's transportation or whether it's surveying or something, where you turn a vertical angle. Vertical angle is called a zenith. All right? It's going to go horizontal up is positive. Horizontal down is negative. So if you're shooting down, that means you're shooting downhill. If you're shooting up, that means you're shooting uphill. Simple as that. But your horizontal angle is turning left to right, like on a highway. Like on a curve on a highway, you're turning left to right. You're turning this way. Vertical angle is like this. On a theodolite transit, you do both. On a level, you don't do vertical. Why? Because level is at 0. And you just turn like this, and you mark all the posts, you mark all the stakes. And then you cut or fill, depending on what you need to fill in or cut, based on the level. Does anybody know what I'm talking about? Some people, maybe? Okay. A level does not turn vertical. A level only turns horizontal. A theodolite or a transit turns vertical and horizontal. And that's the difference between the two. All right, so when you're talking about angle of elevation, this is basically a vertical angle. A vertical angle can also be, from your geometry, one angle on what? Top of the other. So you have to think about contextually, which one are we going to be talking about? We're going to be talking about the vertical angle of elevation. We're not going to be talking about this vertical angle back in geometry. All right? And that's what that's talking about. So if you're talking about this, you could be talking about a mountain, like that, and you're going sending the highway up a mountain. Or here, this could be, what's the opposite of a mountain?
Valley.
The valley. You're doing a shot and you're shooting down and you're going 200 feet and you're setting a point down here, set your transit up right there, shoot up to the top of this mountain, you're shooting, it's called an elevation ring. An elevation ring is when you start at one benchmark and you shoot elevation. You don't even worry about the horizontal angles. You shoot an elevation up here, down here, up here, down here, up here, down here, and then you wrap back around and you finish where you started. Okay? That's called an elevation ring. And that's what's used when you're laying out a highway, or you're laying out a road, or a road of a subdivision. You're doing a cross-sectional study so they know where to put the ditches and they know where the water's going to flow according to the land. That's when you use vertical angles. So if you're doing drainage plans, if you're doing any type of cross-section of a road or a highway, you're going to be using vertical angles. So this is a very good application of real world. Okay? Sometimes I chase rabbits, I'm sorry. But I will tell you this, besides calculus, trigonometry is one of the most applicable maths that you're going to see in the real world. A lot of people say, when are you going to use trigonometry? when are you going to use calculus? Actually, you don't. What you do is you take something apart, you put it back together, or you manipulate it to get the same thing that you started with before. Kind of like taking your tire off, taking the bearing, taking the hub off the tire, taking the brakes off, taking the bearing off, taking the spindle off, and then putting it all back together, making it work right. Same thing. That's why people that build bridges and they don't want the bridges to fall, they take a lot of calculus courses and a lot of dynamics courses and a lot of statics and thermodynamics. So that way the dadgum bridge won't what? Won't fall. That's why you don't have underwater firefighting students building bridges. All right, so the length of a shadow of a building, blah, 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 blah. Find the elevation. This is actually used finding the height of a water tank. I've actually used this in Williamstown. Anybody here from Williamstown?
Where's that?
Okay, Williamstown. If you're from around here, it's called Williamstown. Barely pronounced the T. But if you're not from around here, it's called Williamstown. And I was hired to shoot the elevation of, according to a benchmark I was given, to shoot the elevation of a water tank right there beside the monkey part. Monkey part, if anybody's here from Williamson, you know where the monkey part is, right beside the bylaw. But anyway, this is not the monkey part anymore, now it's just Williamson Park. But anyway, there's a water tank about a mile down the road. And I shot that tank to get an elevation on top of the tank. Nobody's going to crawl up there and shoot a whole rod for me on top of that water tank. Okay? So I had to shoot an elevation to it based off an elevation ring that I brought from a manhole cover a mile and a half down the road. Okay? So when I got to it, I basically just shot to the top, and I got this horizontal, I got this vertical angle, and then I could tell what the elevation was because I could figure out the 34.09 on that picture. And that's how you use the vertical angle. But in this case, length of the shadow of a building, 39, nobody measures shadows. Nobody. I wish they'd put a water tank question in here. But anyway, the length of a shadow of a building, 34.9 meters tall, is 37.62 meters. Find the elevation of the sun. Go ahead and do that. You might want to use similar triangles also. You could use that. Because actually you're talking about something like this. Talking about something like that. Similar triangles. That could help. You know that this is 37.62. You know that this is 34.09. 8.09. Therefore, you can figure what? This angle, they're not giving you that angle.
That's what I was doing. Just
What?
what I'm doing now.
Finding that angle? Tell me what it is. Because I'm going to be honest with you, they're not giving you another distance. You can't find the elevation of the sun. They must be wanting the elevation as far as an angle. Because there's no way you could figure it. What? Without algebra, you have to throw some algebra in there with it.
I got 42 degrees and
11 minutes?
yes,
Check that, please. Make sure that's correct with everybody.
around 10.8
Yep.
minutes. Round it up.
That's fine. 11 minutes
Yeah,
is
I got
fine.
that.
I mean, the sun is only so big. I don't think 1 minute going 500,000 feet will matter to the sun. That's probably what they're wanting, because I don't really think without algebra. Okay, they're doing the tangent. Is that what you did? 4218?
Yeah, the inverse
Okay.
tangent.
Okay, they're not saying the angle of elevation. See, they didn't ask. Okay, this is angle of elevation is not the same as what?
Elevation.
Okay, let me tell you why. The elevation, if point B is at an elevation of 500 feet sea level, what's the elevation of the building, top of the building?
534.5.
That's elevation. Okay, so that's the error. That's the difference between academia and the real world. All right, they're asking for the elevation of the sun. The elevation of the sun is not obtainable, but the elevation angle is. So that's kind of a.
They just
Needed.
missed the word.
There you go. They need to put that there. I'm sorry about being. That just bothers me. All right. Next question. All right. A bearing. And I'm going to leave off on this one because I think probably some people get fidgety and going into zipper fetish. Some of y'all have zipper fetishes. Start doing zipper fetish. Start doing your zipper up and down or something. All right. A bearing. What's the difference between a bearing and an angle? All right. A bearing, just a bearing, is off of north. Now remember, our north arrow is right here. Okay. North. I done forgot the bottom one. There we go. South. All right. And everything, when you're talking about a bearing, is based off, there's two types of bearings, okay? You can have a zenith bearing. Write that down, zenith. Zenith bearing is basically off of north. So if I say 304 degrees, that's a zenith bearing. But I can say northwest, 270 minus what? It's 34 degrees. So that'd be northwest 34 degrees. Which actually, no, it's not. It's 34. It'd be 56 degrees. Northwest, 56 degrees. All your bearings are always off of north or south. A zenith bearing is always off of north. Okay? They're probably not going to go into that. I don't know. They may. I don't know. I have to see. Wonder what happened to our flickering. Stopped.
I mean, the TV's been off, so.
Is that? Okay. Radar stations A and B are on an east-west line. Okay, when you see these type questions on a standardized test, when you see the word east-west line or west or east or bearing east, that means you're going to use north. Okay? Radar stations A and B are on an east-west line with A west of B, 307. So you're going to draw a line between the two dots at 3.7. And then when you do these east-west, you're going to go ahead and draw those north angles. No, I meant north arrows. Go ahead and draw them. Station A, it's over there, detects a plane on a bearing of 61 degrees. Now, when it says bearing, just a regular bearing, that means right now it's off of north. So that means 61 degrees off of north. And then station B simultaneously detects the same plane on a bearing of 331 degrees. Now, if I gave a directional bearing, 331, 270, 61, 39, 29. That'd be northwest 29 degrees. See what I'm saying? So that's a directional bearing versus a bearing. So that's that. So here is 61. This right here is, y'all check my math, I think 29 or 39. 39? 39. Or 29. 29. Doing it in my head a while ago. I did better when I was doing it in my head. 29. And now, of course, you can figure whatever you want, because now you've got the 29. This is called alternate what? Alternate interior angles. And this angle is going to be the same as this angle, because this angle is the same as this angle. Or you could call them what? Starts with a C. When y'all had trouble with the C and the S?
Complementary.
When y'all first walked in, I can't tell the difference between complementary and something. I thought that was one of y'all. Okay. Well, that's complementary, 90 degrees. Okay? So you can use complementary or you can use alternate interior angles, whichever one you want to do. Now, these are puzzles. These are type puzzle questions. And you will see these on the test. Because if you can do these questions, you pretty much can do 4.1 through 4, whatever chapter we on, 8.1 through 8.4 pretty good. Okay, they're doing the same thing here. And it's all where you put what? Where you put your little man. If you put your little man on angle B, then it's going to be different, but you're going to get the same answers than if you put your man on angle A, which is 29 degrees. You're going to get the same answer. And that's, and I hate to say this over and over, but that's why people get confused with trigonometry. They think they don't know about the little man. And if you don't put that little man on one of the angles, you get confused real easy. At least I did. There we are. This is directional bearing. What's more applicable in the real world? Directional. This. Okay? Whether you drive a boat, a plane, or you're driving a car using GPS. You use bearings off of direction, directional bearings. Everything is measured off of north and the south pole, or the north and the south needle, or the north and the south arrow. Okay, see? There's got a southeast and a southwest there. Now, what we're going to be doing is if I give you, and this is where we're going to go with this, if I give you an angle, I give you a bearing of north 45 degrees east, and I give you another bearing of south 45 degrees east, southeast. What's my angle right here? Right. 90 degrees, because 45 plus 45, to take it away from 180, is 90. Now, that's easy because I picked two easy angles. But what if I put 42, 32, 54, and 29, 32, 56? Then you're going to have to add them up and take them away from 180, because this whole side here is what? 180. And you have to take this angle plus this angle away from 180 so you can have this angle. Now, when is that done? That's done in surveying and architecture. Surveying and architecture, well, and construction management. So if you're one of those people going in one of those areas, then you're going to be doing this. Very applicable. These are called directional bearings. And directional bearings convert to angles. Here's an example. The bearing from A to C. A to C is 52 degrees southeast, so you would draw it, 52 degrees southeast. the bearing from A to B, right here, is 84 east. So if I want to figure this angle, I add these two up. I add those two up and subtract from 180. So what's 84 plus 52? 126 or 136? What is it?
136.
136 from 180 is 44. Now you have to be able to do that. So make sure you study a few of these in 8.4, because the problems that we do today, the problems that we have covered today, is going to make up 80% of your test. And these are going to make up a good bit of them. A plane flying at 250 miles per hour takes 2.4 hours, distance equals rate times time, to go from A to B. Find the distance from A to C. Well, distance equals rate times time. There's your rate and your time. 250 times 2.4. You need to write that down for some of y'all that forgot. Distance equals rate times what? Time. 250 times 2.4 gives you 600. Now you've got your angles, because you learned your angle here was 44 degrees. Dang old plus 90. What? 134 degrees. 134 from 180 is 46. Now you've got all your angles and you've got one distance, so now you can put the puzzle together. It's all a puzzle. Don't worry, we're going to go over these on the homework, because some you are going to send them. Y'all keep it down in Pendleton. Y'all settle down. And that's, of course, the same thing we've been talking about right there. Calculating the distance to a star. In 1838, Friedrich Bessel determined the distance to a star called 61 whatever. He used a parallax method that relied on the measurement of very small angles. You observe parallax when you ride in a car and see a nearby object apparently move backwards with respect to the distant objects. As the Earth revolves around the Sun, the observed parallax of 61 blah 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 is theta is equal to 0.000081. And that is information that if you don't know, you won't be able to succeed in life. One of the nearest stars is blah, 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 which has a parallax of blah, 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 blah degrees. Calculate the distance. If the Earth-Sun distance, go back here. Sorry. Earth-Sun distance, that's the adjacent. Well, it's the opposite if you're talking about this angle right here. So draw a picture just like this, and then plug and chug with the information right here. So the angle up top at the star is 0.000212 degrees. And the opposite is 93 million miles. Calculate the distance if the Earth, Sun, so they want to know what distance. And let's see, hold on a second. You can find all the distances really, but we'll look back and see if I can, okay. I think they're talking about D right here. So you're going to be finding the hypotenuse. So if you put that, if you crank that out, you're going to have basically an angle right here. And this is 93 blah, blah, blah. I'm not writing all that out. So if this is the angle, this is angle C, this is C, and this is, if your little man is right here, you're looking at the opposite over the adjacent. So opposite over hypotenuse is what? That's the sine. That would probably be the one I would use. So you got the sine of blah, blah, blah degrees is equal to opposite Oscar had, so that's going to be 93 million, 93 over what? Hypotenuse. So multiply both sides by the hypotenuse. So the hypotenuse is going to be equal to the 93 blah, blah, blah. Let's see. Multiply both sides. Yeah, divided by the sine of blah, blah, blah degrees. Somebody crank that out. Sine of, or 93 million divided by the sine of 0.000212. Somebody give me that distance. Now, I know I'm kind of going fast, but nobody's asking anything, so I'm just kind of, I'm assuming that y'all are like sinking it in or letting it sink in, and hopefully you'll send me some homework questions. What do you get? Okay, everybody's locked down. Everybody's ready to quit. Change your degree into basket weaving gender studies.
I'm very
But you can get a degree in global studies and not know what's going on in Israel. There is a person running for the Senate that got a degree in global studies, and she was interviewed and asked about Israel, and she had no idea how to answer the question. Those are the kind of people we send into Washington.
Are you talking about in New York?
Yeah. Golly,
Yeah.
somebody actually, let me sit down. Somebody actually knew what I was talking about. Wow. Yeah, she's been asked. They finally took her off have you noticed they took her off of TV now?
Yeah.
Because she's
that's
dumb as a
probably
post. She is dumb as a rock.
Was it Cortez?
Yeah.
I mean, that girl, she needs to stay off of TV because she's losing votes left and right. Let's see, she's minored in global international studies, but didn't know anything about Israel. Probably the hottest spot in the world. Didn't know anything about it.
Even I know about Israel.
Well,
All right.
you need
they'll
to
tell
take
her what
global
to
studies in. You enrich your global studies. What'd y'all come out with? Okay, I heard mumble.
Mumble, mumble, mumble.
2.51 times 10 to the 13th power.
2.51 times 10 to the what?
13.
Is that good for y'all?
Yep.
Is that what everybody got?
Ridiculous. I was like, that can't be right.
That's called scientific notation, people. You take, come on now, 2.51. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's called a BA number. What does the A stand for? Attitude. Let's say that's what? A million, a billion, a trillion, a zillion, 25 zillion. I don't know what comes after trillion.
Quadrillion.
Okay, quadrillion. 25 quadrillion, that's enough. A light year is defined to be the distance that light travels in 1 year and equals about 5.9 trillion miles. Find the distance. Well, what did we just find? All right, we just found the distance right here. C is equal to 2.51 times 10 to the 13th power. Okay, now what are they saying now? A light year is defined to be the distance that light travels in 1 year and equals about I think they want to divide.
Yeah, they just want you to
Yeah.
put the big number out by 5.9 trillion.
Okay, so 5.9 trillion is what? 5.9 is, let's see, million,
5 trillion.
million, billion, trillion. That's 1, 2, 3, 4. That's to the 12th power. Somebody check me. 5.9 times 10 to the 12th divided by into 2.51 1 times 10 to the 13th. So that's 10 to the first. And somebody take 2.51 divided by 5.9.
That's gonna give you 0.425.
0.425, so 4.2 light years.
Yeah, 4.2.
Y'all feel good about yourself? So you don't put smokestacks on your truck? Or you put too much makeup on? 2.51, look, we got that right. Woo. We feel good about ourselves. Okay, 4.3, I'm sorry, I was off a tenth of a light year. The shuttle just blew up. It's my fault. Somebody's going to say I'm offended. Francisco needs to know. Oh, Francisco. I like to say that sounds. Francisco. They're purpley today. Where's that movie? Does that come from?
What?
The Elf.
Oh, really?
I believe it.
I hate it. I have to watch it every year because of my kids. Can't stand
I'm
it.
so sorry.
What?
I said I'm so sorry.
That I have to watch it?
Yeah.
I can't stand it. I can't stand that movie. Francisco. Oh, you look very purpley today. Francisco needs to know the height of a tree. Again, you could use that as a water tank, infrastructure. But I don't know why they don't put infrastructure problems on these. Because like you're going to go out and look the height of a tree.
Yeah, well, you need to.
Unless you work for who's in charge of the airplanes, FFA or whatever? Not FFA. Who's in charge of the airplanes?
AA, I think.
What is it? Federal Avionics?
Aviation Authority.
Yeah. They're interested in the height of trees, and if you got a tree in the wrong place, they just bulldoze it down. Okay? They don't care about the tree huggers or the paper or save the trees or anything. If you got something in the way of a dadgum runway, they condemn it. What's it called when they take over stuff?
Eminent domain.
Eminent domain. They eminent domain it and they just railroad it down. And they ain't nobody standing in front of FFA or FAA hollering about tree hugging. They just bulldoze you. They don't care. So they probably know the height of trees. So find out the height of a tree. Now this is where you're going to have to use your algebra. This distance right here is not 50. What is it? X plus 50. So write that down. Make a note of that. The base of this triangle is not 50. It's X plus 50. You've got two triangles. Where are they, Hubert? Well, you've got one that's X plus 50, and the other one is X. There's two right triangles. There's the little right triangle. I'll take my handy dandy highlighter.
Oh.
There's one right triangle. I had to pick green, didn't I? And then here's the other right triangle. There's two right triangles there. So, I don't know. I have no idea what to find, but I do know that similar triangles, I'll just draw a picture. I'm about ready to quit, y'all. I'm just about ready.
Fine there for a second.
I'm about ready to quit.
Oh.
Well, hell, where is it? There it is. Okay, let's try this again. I'm going to hit it 5 or 6 times. All right, so we're going to do black. And I'm going to set up one triangle. Looks like that. And that's going to be X plus 50. And this is going to be H. And that angle is what? 22.2. And then the other triangle, H, wait a minute, these two are what? They're the same, so we can set something equal to each other. Wow. So 36.7 over X. So X over, and however you want to do this, we know H is part of it, okay? So H is equal to, if I want to find H, I've got the angle here, and I've got the adjacent. Oscar had a hunk. Oscar had a hunk, so that would be cosine, right? Based on the cosine?
Yeah.
Cosine of 36.7 is equal to adjacent, which is X, over what? H. And then the cosine of 22.2 is equal to X plus 50 over H. Now solve both of them for H. So I'm going to multiply both sides by H. And H is equal, on the first one, X over cosine of 36.7. And this one is going to be X plus 50 divided by what? Divided by cosine of 22.2. And now I find the cosine of 22.2 and the cosine of 36.7. I multiply them together and I multiply the whole thing by the common denominator. Or I can what? Cross multiply and what? Cross multiply and solve for X. Algebra. Dang old Algebra 1. So which one y'all want to do? Y'all want to go home, don't you? Have I done short-circuited some of your brain waves? I'm sorry. Multiply both sides. Somebody multiply cosine of 36.7. What's the cosine of 36.7? 36.7. Just give me a decimal.
0.8.
0.8? All right. Multiply cosine of 22.2.
0.9.
I'll do this for you. 0.72. So multiply both sides 0.72. So 0.72 divided by cosine of 36 is 0.9, so that's going to be 0.9x, is equal to, cosine of 22 is 9, that's going to be 0.8 times x plus 50. And that's going to be 0.9x is equal to 0.8x. What's 0.8 times 50?
Let's see.
That's a yawn. No yawns in
40.
class. What?
Just 40.
40.
40. And I'm going to bring the 0.8x over, and it's going to leave me with 0.x. 0.1x is equal to 40. Somebody divide 40 by 0.1.
You get 400.
400. So x is equal to 400. If x is equal to 400, what's x plus 50? 450, and now you can fill out the whole thing. Let's just make sure, and we'll stop after this one because some of y'all are like, what the hell? Because I see Pendleton sitting there going, half of them are saying, I understand, half of them just gave up 20 minutes ago. And easily, I can't tell with easily because they got poker faces. So, Miss Whiten, what do you think?
I'm getting it.
Okay, good. All right, then we'll have a test tomorrow then. Now they're going through and doing it a different way. What did I get? They're going. Okay, they're going through. They didn't find this distance, but that's part of it. But you're gonna find that, and then you can find that. Because once you find that, you can. Once you find this 400 right here. Let's see, what would that be? Let me finish this, and then some of y'all was zipping fetishes. Just hold on. Let's see. That's going to be what I came up with. 400 feet. 400 here, H here, and 36 8.7. So I got adjacent, opposite, right? Opposite over adjacent, which is going to be tangent, 400 tangent. Somebody give me 400 tangent to 36.7. 400 times the tangent of 36.7.
298.15.
300 feet. Okay, 298. Is that what you got? Oh, something else, engineer. What is the rule of engineering? Always round up, because there's always going to be a 600-pound woman or a 600-pound man. So you always want to make sure that I-beam is strong. Now, before somebody gets offended, that's what my Clemson professor used to say all the time. Always round up. I don't care if it says 295. Round that sucker up to 300. Some of y'all just have no idea. Just sitting there and just head on a bull. What did they get? Did they get an answer? Oh, we got the wrong answer. We must have done the wrong one. They got H is equal to 45. We'll go back with it tomorrow. Thursday. We'll finish this Thursday. All right. Let me get the roll, and y'all can head on out. I'll have to see what I did wrong on there. But the whole gist of it is set it up like a similar triangle, and you shouldn't have a problem. I'll go ahead and call Pendleton first because they're getting so excited. Pendleton, are y'all like this in all y'all's classes?
Very much good.
Today is 9/11. I don't say anything about 9/11 because I don't want nobody to be offended.
One of my friends was born.
Armstrong.
Here.
Bitely.
Here.
Brown.
Here.
Carlin. Cunningham.
Here.
Evans.
Here.
Gusmus.
Here.
Baviner.
Here.
Lofton.
Here.
Nitz.
Here.
Ludiger.
Here.
Santana Flores.
Here.
Schaefer.
Here.
And Radford.
Here.
And not Miss Whiten, Miss Crittenden. I'm sorry.
Right here.
I got you. And the fearsome foursome at Easley. Y'all there? 4? Yep. Got you. And Anderson. Arocho. Bennett.
Here.
Heather.
Here.
Lee is here. Lindsay. Oh, here. I'm sorry. McGahee.
Here.
Nettles.
Here.
Reese.
Here.
And Shingleton. Anybody got any questions? Work on 8.4 and I'll see y'all Thursday.
I have a question.
Yes, ma'am.
I
Where's
was
it coming
able to
from?
see
Yes.
Pennington. Can you see me? I'm not able to see the due dates anymore. What did you say something about it today?
Yeah, I took them off right now. You on the homework, so it's open.
Right. I just wanted to know when it's due. When is
We
the
don't know
first
yet.
test?
When we get through with 8.6 and 8.7.
Oh, so that's when our first test is?
Yeah, we'll do it in class. We'll do the test in class. I'll assign the test, and I'll assign the homework deadline.
Okay. So that day we do the test in class.
Yes,
Okay.
probably be after 8.7.
Okay, gotcha.
Okay? I didn't even know you were sitting there. I can't see you.
I know, everywhere I sit, you can never see me because you can never see that side of the room either.
Yeah, don't worry about the dates because I don't care about dates. So when I get close to the end, you'll start seeing me. I'll start saying something. And then when we get to the end, I'll say, okay, it's time to go over the test. We'll go over it in class, and then I'll set the dates.
All right, sounds good.
Okay?
All right,
Have a
thank
good
you.
day.
You too.
And speak up. Why can't you get them people in Pendleton to speak up?
I don't know. Most
Gosh.
of them, they're guys.
It's like teaching a
Class
bunch
full
of
guys. There's only
frauds.
3 girls.
I know. Well, y'all need to start
Or 4, I
talking.
think. I know.
It makes the class a whole lot better when you talk. I can't get them to understand that. Are you Miss Flores?
Yes, I am.
Okay.
Yeah, it was me.
Okay,
Yeah.
that's why I never can see you. You're always sitting up there toward the front.
Well, yeah, I'm always in that corner too, or when I'm late, I'm always like in this little corner, so it's like,
Okay. All
I'm
right,
still
well, have a good
hitting either
weekend.
way. I don't know why.
That's all right. Have a good weekend or a good week. I'll see you Thursday.
Yeah, Thursday.
Okay, bye-bye.